So off we go in Algebra 2, Chapter 6. If you scan through the board and think, that looks familiar, have I done that before? The answer is yes. Okay, so Algebra 1 had a whole chapter about a thing that some people will call fractional expressions, some people will call rational expressions. It's two names for the same thing. It doesn't really matter which terminology you use. All tend to usually say rational expressions. The difference today, I think what we're doing today was probably like 3 different lessons from Algebra 1. Okay, so we're going to talk about simplifying these rational expressions, which I think in Algebra 1 is its own day. We're going to multiply some rational expressions, which I think in Algebra 1 was its own day. We're going to divide some rational expressions, which I think was the third day. But we're just going to lump it into a day because it's all sort of interrelated. If you look around the board a little bit, what old word that we just got done doing do you see already up here a couple times? Simplify is an old word, that's true. A more recent word. No. Last chapter we did this.
Is it factoring?
Factoring is correct. So last chapter we spent like the whole chapter factoring. You still need to be factoring in this chapter. So little quizzes on factoring, still alive and well. But goal 1 is rational expressions are basically just fractions that have polynomials in them. They have algebra stuff in them. So if you're looking at a fraction but there's algebra stuff in it, you are looking at a rational or fractional expression. So what we're trying to do here is the algebra equivalent of, if I said to you 6/8 in elementary school, you started to learn that 6/8 is better to be 3/4. Okay. We're going to basically look to continue to reduce our fractions in the same way. To reduce fractions, we're probably going to need a factor. Not always, but I say probably going to need a factor, and that's going to let us cancel some things. The point of factoring is to create a multiplication situation out of an addition situation. So right now, we cannot come in here and start canceling things, because the adding, or in this one, the subtracting, you can't cancel things that are involved with adding and subtracting. You can only cancel things that are involved with multiplying and dividing. Right here, we're ready to cancel right now. Why are we ready right now to cancel on this one? Because there's not an adding or subtracting. Okay, this is already only multiply and divide, so we're ready to just cancel. So I'm going to say factor probably, 90% of the time, but cancel definitely. So what would be a pair of things here that you could cancel?
5 and a 10.
5 and 10. If you cancel 5 and 10, you'd have to leave a
1 and a 2.
The 1 and the 2. For sure you have to leave the 2. The 1 would even be debatable, but 5 goes into 10 twice. Absolutely need to leave a 2. Doesn't hurt us to leave a 1, but maybe we don't even need that. Maybe we do. How about the x's? If you cancel some common x's,
1.
there would be 1 x on the bottom, because the bottom had more. So 3 x's can bump off the 2 x's and get a single x on the bottom. So our simplified answer? 1 on top of 2x. And we did end up needing to at least think about that 1 being there. Question about that one, we just had to cancel. This one, again, we can't just cancel. You can't just start crossing off x and x, or 6 with 9, or 3 with 18, or anything with anything. Why on this one are we not cancel ready? It's not multiply. We need to make a multiply problem by factoring. So how can you factor the top? Take out a 3, which leaves you x plus 3. On the bottom, take out a 6. That leaves you x plus 3. Now this is multiplying. The 3 is multiplying that. The 6 is multiplying that. Now we can cancel. Who can cancel? X plus 3's are a perfect match. Cancel. 3 with 6 leaves you a 1 and a 2. So answer is a half. Question about that one. Okay, third one. Either factor the top or factor the bottom, doesn't matter. But again, you can't cancel yet because there's too much adding and subtracting going on. We're going to have to make some factors. And then you're going to be allowed to cancel the factors, because factoring means it's now a multiplication problem. Anybody factor top or factor bottom?
X plus 3, x plus 3.
X plus 3, x plus 2 for the top works for me. X plus 3, X minus 3 works for me for the bottom. It doesn't matter what order you put those in. When you would cancel them, get rid of
X plus 3.
X plus 3's. They're matched, so get rid of them. So this would have X plus 2 on the top, it would have X minus 3 on the bottom, and you call it a day. Question about that. Some people might wonder, nobody's asking it right now, do we need to write those?
No.
No. Could you write them?
Yeah.
Yes, because whether you write them or you don't write them,
They're there.
they're there. Just like this has a 1x squared and a 1x squared, and some of these other things have stuff like that. Whether you write them or not, the parentheses are there. Whole tops, whole bottoms, they always have the parentheses. Whether you choose to write them or the book chooses to write them or not, they are present. So whether you do or don't do that, no one cares. Question about topic 1, simplifying. With 1 down, 3 to go. Topic 2 is multiply. So it's just like multiplying fractions. 7th grade, multiply fractions, you go straight across. So sometimes, some of these problems, all you have to do is go straight across. Sometimes though, I think you save yourself some bother by factoring so that you can cancel before you go straight across. Okay, so if I gave you this problem that's more of a 7th grade kind of question, could you multiply straight across and get like 360 on top of 840? Like, you can, but I think your life is a whole lot easier to go like this. 3/7. So, same thing applies today. Multiply straight across is always fine, but I think you're going to save some bother if you can factor by factoring and then potentially cancel. On this, is there anything that you can factor? Any factoring? No. Can I cancel right now? Like, could I cancel 3, 6, leave 1, 2? No. Why not? Because they're involved with adding right now. If that confuses you at all, go like this. These parentheses are there. If writing them makes you feel a little bit more clear about what's going on, this group cannot cancel that group, which means this little piece can't cancel that little piece. You know, this little lonely x can't cancel that little lonely x. They're involved in adding right now. So if that's unclear, put parentheses around all of those pieces, and then life maybe gets a little more clear. Now I get down here, if I go like this isn't necessary to do, but maybe that clarifies like what we have. So if nothing cancels, just multiply straight across. So on top, I'd have I could. I'm not even going to do that. I'm going to write x squared and x plus 3. If I wanted to, I could distribute that, but if I distribute it, is it going to get bigger or smaller? It's going to get bigger, and generally in math, people prefer things smaller. So you're not wrong to distribute it, but I think it's unnecessarily going to make it just look worse. So bottom,
X plus 4, X plus 6.
x plus 4, x plus 6. Now it's possible, if you wanted to, you legally could,
You would out.
what's that called?
Foil.
You could foil it, but if you do, it's just going to get worse, so I don't really see a great reason why to do that. I just go there. Something about that one. This one, I won't go straight across first. Why not?
You can take some stuff out.
Because I can take some stuff out. Who can go?
X plus 5.
X plus 5s, or an exact match, they're out.
4 and 8.
The x's, because these are involved in multiply, these are involved in multiply, the x's can go. 4 with 8 can leave 2. So grand total is a half. Question about that. Okay, this last one. Maybe go like this if it makes you feel better. can any of those four things factor? Top right can factor, so I'm going to replace that with two smaller friends. How's that top right one going to go? X plus 3, x plus 1 is true. This is no longer there. That's just been eliminated. I can sort of still see it, but it's not there anymore. Question about the factor? Then cancel. Who can cancel? X plus 1s can cancel. Anything else? Nope. So, answer, top.
3x plus 1, x plus 3.
3x plus 1 as well as x plus 3. Bottom,
X plus
x plus 2. On top, I have to write the parentheses because there's a couple factors, so we need to keep them away from each other. The bottom, if I wanted to write them, I could. I generally choose not to, but if you like to, you can do that. There would be no harm with you throwing that in parentheses. They're there whether you write them or not. Question about topic 2. 2 down, 2 to go. Take a hesitation and stroll left with our camera. Okay, so third topic I'm going to call dividing by a monomial. Just quick reminder, monomial means you just have one term. So this problem, I'm dividing by a monomial. I just have a 6 down there. I'm only dividing by 6. When the book writes these, they could write these one of two ways. They could either go a bunch of stuff on top of a 6, or they could throw this bunch of stuff in parentheses and then write divided by 6. But that means the same thing. I'm not going to write it both ways. But if you see parentheses, divide by 6, that's the same as this, dividing 6. You could do this the same way we did over there. So if you would like that idea, I'll talk about it, but not do it. What could you do in terms of factor cancel here? Who could come out? 6. You could take out a 6, leave a bunch of stuff, and then the 6's could cancel. That's fine. I think that's a harder way to think of it, but if you like that, that's perfectly valid. What I like to try to do is just divide this into each thing. Kind of like tear this fraction apart. That's a fraction we can attack. Attack that. And attack that. The 6 is going to go with everybody. This is essentially buy one fraction, get two free. There's 3 fractions there. So if we deal with this, that's going to make 3x. Deal with this, or y. Deal with this is 6. I think that's the easiest way to think of that, but everything that I said in the last 2 minutes was all valid. Question about that? What if this were like a 37? What do you think?
Put 37 over 6.
Just put 37 over 6. If a couple of them cooperate and one of them won't, just do the ones you can and just leave the other one still in fraction form. That's fine. Question about topic 3. 3 down, 1 to go. Okay, the last thing we're going to do is divide, kind of like how we multiplied. The final column over there when we were near the dates and how many days of school were left kind of information. The way we multiplied over there, we can divide the same way. What was the only difference, though, in fraction land from your history of divide compared to multiply? Yeah, the old keep, change, flip, copy, change, flip, however you say that. What we're going to need to do is flip the second fraction. If you get the second fraction flipped, you're good. Otherwise, dividing is the same process as multiplying. So I'm going to look to factor, I'm going to look to cancel, but I'm going to need that last fraction upside down. So can we factor this? First top? Yeah. How's it going to go? X plus 4 and x plus 1. So this is out. Try to factor bottom, or we're cool with that?
Take it with 4s.
We will eventually, but do we need to factor this? No, it's fine. Some people might feel better if I went like this, but that just is what it needs to be. This one, can this factor? Yeah, how's that gonna go?
X plus 5, X plus 1.
X plus 5, X plus 1. I'm gonna write that down here though. Why? I gotta flip the second fraction. So my stuff from the top, I'm gonna move to the bottom, and therefore the stuff from the bottom go up top. Can this factor at all?
Yes.
Take a 2 out. So this bottom, take a 2 out, and leaves X plus 1. So step 1 is still factor everybody, but I'm gonna do also at the same time like step 1A, I'm gonna flip the second fraction. I'm gonna put stuff upside down. So cancelable pairs, X plus 1s for sure. So there's 1 on the top, there's 1 on the bottom, so get rid of those. X plus 4s, so out of A and B and C. Are we gonna cancel all 3 of those at once? A with B, A with C, B with C. Who's gonna cancel with who? We could do B and C. We could also do A and C. You can do any top with any bottom. So could A cancel B? No, because they're both tops. But we could either do A and C out, or you could do B and C out. You just need partnerships, 1 top, 1 bottom. So I think somebody first said B and C, so I'll get rid of those. So who's left standing for the top? X plus 4 is up there.
2 on top.
Also a 2 on top, so try not to be messy and lose track of what you scribbled out and ditched. Bottom, X plus 5. And that's where we are, and we can more or less call that a day. So where we're headed, homework life, there's a 249. 249, we're gonna work from 5 to 38, and we're gonna skip the 3s. So the first part is gonna be like what I did first, simplifying, which means probably factor, definitely cancel. Then there's a multiply group where we are gonna definitely factor and definitely cancel. Go straight across with who's left. There's a divide group, which is, I think they're all like this third group, where you're gonna have to factor and flip the second fraction. I don't actually see any like, no, I do see a couple like that. They're hiding through the group. But when you look at the homework, it looks like there's 3 groups. It looks like there's a simplify group, a multiply group, and a divide group. But these are like kind of hiding in some of the other groups. They are around, but they don't have a group of their own. So one more time on that, 249, we're skipping the 3s, we're working 5 to 49, and that's a wrap on that.